Fascinating high-stakes drama involving our immune system. We're finding more and more that ADHD often brings along unwanted plus ones like allergic and autoimmune diseases, suggesting that underlying inflammatory status might be pulling the strings behind the scenes. At the heart of this internal brain inflammation are mast cells. Usually we think of these guys as the culprits behind seasonal sniffles, but they are also major players in neuroinflammation. When mast cells get grumpy, they release inflammatory factors that bother our glial cells and neurons, creating a bit of a localized storm. This tension can even mess with the hypothalamic pituitary adrenal axis and weaken the blood-brain barrier. When that happens, the behavioral profile shifts, making things like substance misuse, oppositional defiant disorder, conduct disorder, depression, and PTSD much more likely to show up. To understand why we look at the brain's neighborhoods, places like the dopaminergic and noradrenergic pathways, the serotonergic system, and the cortical and subcortical regions. Think of the nucleus accumbens, the amygdala, the caudate nucleus, the hippocampus, and the putamen as the main power grid. Even common treatments like methylphenidate are essential, trying to manage how these areas talk to each other while calming down the resident microglia and astrocytes. But as we return to the mast cells, they actually start out as hematopoietic stem cells, expressing the CD34 marker before maturing into elite antigen-presenting cells. They are packed with electron-dense cytoplasmic granules containing heparin and histamine. While you can find them in the choroid plexus and the parenchyma, they really love to hang out in the subthalamic nucleus and the hypothalamic region, often standing guard near endothelial cells and pericytes. When they sense trouble, be it immunoglobulin type E or even just corticotropin-releasing hormones, they undergo degranulation. This explosion of chemicals is quite the cocktail. A sudden rush of histamine, tryptase, and chymase, followed by a wave of interleukins, tumor necrosis factor, alpha, and serotonin. They even pump out vascular endothelial growth factor, prostaglandins, and leukotrienes. These chemokines and cytokines act like a loud siren, triggering T-cell proliferation and attracting even more immune cells into the brain. So while ADHD might look simply impulsivity or distractibility on the surface, underneath it's a complex symphony of immunoglobulins and inflammatory processes. Systems are constantly talking, and sometimes that conversation just gets a little bit too loud.